Thank you so much. Hey, everybody. Hope you're doing wonderful. Let me go ahead and share my screen. And please let me know if you can see it. Give a thumbs up if you can see it. All good? Okay, excellent. All right, I'm going to go ahead and start presenting. Let me start my timer just so I get a sense of how things are moving along. Okay, thank you so much for having me. My name is Gabriel Cardona. I am developer evangelist from Ava Labs, and I'm very happy to be here. This is a very exciting event I've been looking forward to. Today, we're going to be doing an introduction to Avalanche. So we're going to discuss who I am and who Ava Labs is, but then we're going to do an overview of the Avalanche tech stack and platform. And then we're also going to discuss the challenges that we have issued along with the rewards. And then we're also going to discuss our development environment, the different components of our development environment. And then we're going to see what it looks like to walk through a couple little code snippets, firing up a local network, calling some RPCs, issuing a token, sending some stuff around, just to give you guys a sense of what the workflow looks like. And let's go ahead and get started. So this is Introduction to Avalanche. So first, who is Ava Labs? So Ava Labs is a world-class team of experts in the fields of computer science, economics, law, and finance. And we are primarily based out of Ithaca, New York and New York City, but we are really a worldwide team. I myself am based in the San Francisco Bay Area on the west coast of the United States. And I have teammates on nearly every continent. I don't think we have them all covered, but we're definitely getting close. And we are always hiring. So if anything I talk about today resonates with you, please go check out avalabs.org/careers. We are always looking for creative and easy to get along with and hardworking people who want to have a radical impact with their life and their work. So if what I talk about today resonates with you, please reach out to us. Who am I myself? Well, as I mentioned, my name is Gabriel Cardona. I'm developer evangelist at Ava Labs. And so I spend a big part of my time going around to conferences and meetups and hackathons and conventions similar to this one and giving presentations with the intention of inspiring developers to on-ramp into our ecosystem. And I've said this before, and I genuinely feel this way. I believe that a competent developer is the most valuable asset on the entire planet at this time. And the reason I say that is I believe that we're at the time in the evolution of our species where we really need to solve problems at scale and at velocity. And fortunately, thanks to the many radical breakthroughs we've had in computer science over the last 100 years or so, we have raw intellectual material like no time in all of human history. So what we really need now are creative and hardworking people to build the systems which solve the problems. And so there has never been a better time in all of human history to build something amazing and to change the world. And so hopefully over this next 10 weeks at this hackathon, we can inspire you to build a game-changing decentralized app or a unique financial product. And hopefully, of course, we can inspire you to build that on the Avalanche network. So the next question is, what is Avalanche? So Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable millions of validators to process thousands of transactions per second with near instant finality. And we do that using a protocol which is completely green and quiescent. And we paired this extremely high throughput fast finality protocol with an architecture which can meet the unique needs of financial products and decentralized applications. And we have accomplished this through this notion of subnets. So subnets allow anyone anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. So Avalanche really lays the foundation for this platform of platforms with thousands and thousands of these public and private networks all emerging into this global marketplace, which we call the Internet of Finance. And so I have found in life, it helps if you have an appreciation of where you come from so you can really have an appreciation of where you're going. So I want to give a brief history on the evolution of the blockchain revolution. And I suspect that these next few slides won't really be news to most people watching this right now, but again, I think it's important to understand where you've come from so you can really appreciate where you're going. So this is a brief history on the evolution of the blockchain revolution. So we view Bitcoin as blockchain 1.0. And Bitcoin proved to the world there was the need for a decentralized and a robust payment network. The problem with Bitcoin, if you want to call it a problem, is that frankly, it's just really slow. It only does a handful of transactions per second, and it takes around an hour for you to be confident that your transaction has settled. And it's sort of hardwired to do payments. It doesn't really do, it does tokens, but it doesn't do them that great. It does smart contracts, but it doesn't really do them that great. Bitcoin is really a payments network, and that for better or worse. So that's blockchain 1.0. We consider blockchain 2.0 to be Ethereum. And so Ethereum is a decentralized application, which allows developers to launch other decentralized applications on top of it in the form of a smart contract. And to appreciate why that's a big deal, you need to appreciate how challenging it was to do that prior to Ethereum. So prior to Ethereum, if you wanted to launch your own decentralized app, you really needed to launch your own network. And because of that, there was this very bespoke environment where there were a bunch of different decentralized apps, but none of them were able to get the network effect required to ultimately tip and go mainstream. And clearly Ethereum accomplished that and has led to a huge wave of innovation around tokens and smart contracts and initial coin offerings and oracles and decentralized finance, and the list goes on and on. So that's blockchain 2.0. Blockchain 3.0 is Avalanche. And similar to blockchain 1.0 and blockchain 2.0, there are a handful of new paradigms which we're introducing, which I'm now going to discuss. So the first is a network of networks with compound network effects instead of being a single blockchain, a validator set. The second is that you launch your application as a virtual machine and not a smart contract. The third is that we have dynamic sets of validators called subnets, which can validate your blockchain. And then the last is Avalanche Consensus, which is a huge radical breakthrough in the computer science field of consensus. So let's briefly touch on each of these. So the first thing to wrap your mind around is, in the old way of thinking, there was one blockchain and one set of validators. So think about BTC and their miners, or Ethereum and their miners. In Avalanche, we are a heterogeneous network of many different blockchains and many different validator sets. So the very first thing you have to wrap your mind around is that Avalanche is a network of networks with compound network effects. The second thing you want to wrap your mind around is, in Avalanche, you do not launch your decentralized app as a smart contract. You launch your decentralized application as a virtual machine. And so technically speaking, a virtual machine is a state machine. It has the state of your blockchain, a state transition function, transactions, and then an API through which users can interact with your blockchain. And this logic can be nearly arbitrary. So we don't put a lot of restrictions on what you can do with your virtual machine logic. So the creative space out of which you can pull your virtual machine is really nearly infinite. And developers who launch their applications as virtual machines get a few different benefits. So the first benefit they get is that you can use modern tooling. You're not boxed in to use something like Solidity or Viper. You can use a tech stack which is more in line with your day-to-day tech stack, something which feels a bit more modern. So for example, you can use Golang, or you can use Rustlang, or you can use C++, or ... The list really goes on. You'll ultimately be able to use anything you want. And as an application developer, you don't have to worry about the underlying networking. You don't have to worry about the underlying state. You don't have to worry about the underlying consensus. All of that is handled for you by the Avalanche network. And each one of these virtual machine launches on its own blockchain. Another way to say it is a blockchain runs a virtual machine. A blockchain is really an instance of a virtual machine. Another way to say it is as a blockchain runs a virtual machine. And each one of these virtual machines can be instantiated multiple different times. And so one virtual machine or one blockchain is validated by exactly one subnet. So that's the next thing we want to wrap our minds around. Subnets. So subnets are dynamic sets of validators working together to come into consensus on the state of a set of blockchains. And subnets are incredibly powerful. First off, they manage their own membership. So whenever you fire up a subnet, you set several things. And two of the things you set whenever you configure, I should say, whenever you're firing up your own subnet are, you set a threshold. So the threshold is a number, let's say the number 2 in our example here. And then you also pass in a lexicographically sorted array of addresses. Let's say we pass in 3 addresses in our example here. So what that does is that tells Avalanche, nobody can make any changes to my subnet. They can't add any validators. They can't add any delegators. They can't instantiate any virtual machines as blockchains. They can do nothing at all to my new subnet unless 2 out of these 3 addresses sign a control threshold signature. And so this idea of having the spectrum with one end being completely permissionless networks, and then the other end of the spectrum being completely permissioned networks, really opens up this entirely new world of legally compliant blockchains and networks. So imagine being able to say, for example, all of the validators in this validator set need to be within this certain legal jurisdiction, such as the United States. Or all of the validators in this validator set all must meet certain KYC AML requirements. Or all of the validators in this validator set have to have certain hardware requirements because we're building a very, very powerful network. Or every single address for every single blockchain in this validator set has to have a certain professional license mapped to it, or something like that. You can immediately get a sense of how powerful subnets are just from that. And the way you can visualize this hierarchy is as follows. A virtual machine is a blueprint. It's the application level logic of your blockchain. And a virtual machine can be instantiated as a blockchain. So a blockchain is an instance of a virtual machine. And one virtual machine can be instantiated many different times into many different instances of blockchains. One blockchain is validated by exactly one subnet. And one subnet validates many different blockchains, including many instances of the same virtual machine. And one validator can belong to many different subnets, some public, some private, validating many, many different blockchains, including many, many instances of the same virtual machine across different public and private networks. So you can get a sense from that visualization how rich and diverse in character the network will ultimately grow to be. We use the word heterogeneous to describe it because that is the best description you can get. Rich and diverse in character. That's the nature of our blockchain. And so the final thing we need to wrap our mind around is Avalanche Consensus. So consensus is the process by which a series of independent validators come into agreement. And so it's a very, very rich field of computer science. It goes back at least 40 years. And there have been 3 major paradigms in consensus. So the first one was called classical consensus. And classical consensus has very fast throughput and very fast finality. And it's green and quiescent and lightweight, but it does not perform well in adversarial conditions. And it's not really scalable and robust. In 2008, 2009, when Satoshi Nakamoto launched Bitcoin, he or she or they or it turned on the world to Nakamoto consensus. And that's the second paradigm. And Nakamoto consensus is certainly robust and decentralized, but it does not have great throughput, only a handful of transactions per second. It doesn't have fast finality. You know, it takes 6 blocks or up to an hour before you can be confident that your transaction won't be double spent. It's not light and green or quiescent. We know for sure that BTC burns more energy every single day than some nation states. And it performs okay in adversarial conditions up to 51%. A couple years ago, there was a breakthrough in distributed systems called Avalanche Consensus. And Avalanche Consensus uses repeated random subsampling to ultimately achieve this perfect storm of features that we would want from consensus. So it's decentralized and it's robust. It has very high throughput, thousands of transactions per second. It has extremely fast finality, oftentimes less than a second, sometimes a 20th of a second or even a 50th of a second. And it's lightweight. It can be run on a Macintosh or a PC or a VPS droplet or even on a Raspberry Pi. The Internet of Things is a huge paradigm that's about to break in a big way, and Avalanche can work on a Raspberry Pi. It's also very quiescent, and it performs well in adversarial conditions. And so we have this really great data visualization here that was created by our co-founder and CTO. His name is Ted Yin. Ted, prior to working on, at Avalanche, or Alva Labs, I should say, was actually one of the co-creators of Hot Stuff. So Hot Stuff is the classical consensus protocol, which is behind Facebook's Libra network. So I just think that really speaks volumes that Ted, who was one of the co-creators of Hot Stuff, which is the technology backing, Facebook's huge payment network, is no longer working on that. He's now working on Avalanche Consensus at Alva Labs. That speaks volumes. And so this data visualization will hopefully give you an intuition about how Avalanche Consensus works. So the grid you see here, it represents a bunch of different nodes. Every single square is a different node, and its color is its proposal. So it's either going to be orange or blue, and then the darkness of its color is its conviction for this proposal. So when I click play here, all of the different squares are going to start repeatedly randomly sampling each other, and then they will either make their color darker if they increase their conviction, or they will flip from blue to orange or back and forth based upon what their peers return. So let's see how this works. So you can see that it only takes a few rounds of sampling before everything tips and avalanches into consensus. I want to replay that because I think it's absolutely beautiful. So you can see that it only takes a few rounds of sampling and everything just tips and avalanches into consensus. So hopefully that gives you a bit of an intuition just around how Avalanche Consensus works. So again, there are 4 paradigms. We're a network of networks. With compound network effects, you launch your applications as virtual machines and not smart contracts. Virtual machines are the application level logic of your blockchain. Each virtual machine is instantiated as a blockchain and validated by a dynamic set of validators, which we call a subnet. And then we have Avalanche Consensus, which is a radical breakthrough in the field of computer science known as consensus. So now I want to briefly discuss the cryptographic primitives that we use in the networking layer and in the primary network. So we use transport layer security certificates to protect node-to-node communication from eavesdropping. And it's very important to note that the Avalanche network is not dependent upon any third-party certificate issuers or authenticators. Every single certificate which is used in our networking layer is self-signed. And this creates a truly self-sovereign identity layer for the Avalanche network. And of course, we think that's very, very powerful. We also use TLS addresses. So we use your TLS cert to identify your node for communicating with peers and for doing validating and staking, etc. And so we don't want to store your entire TLS certificate onto the blockchain. So what we do instead is we take the DER representation of it, we SHA-256 that, then we take the resulting digest and RIPE-MD160 that, and then we take the 20-byte representation and we base 58 check encode it and prepend that with the string node ID dash. And so it's worth noting that our base 58 follows the exact same standard as Bitcoin, and our checksum differs in that we only SHA-256 one time. We don't do it twice. Other than that, our check base 58 is the same as base 58 check from Bitcoin. As I mentioned, the difference between our base 58 check and Bitcoin's base 58 check is that they SHA-256 twice, and we only do it once. So if you have ever run Avalanche Go, if you're running your own full node today and you go to the JSON RPC and you call info.get node ID, it's going to return you a node ID. It's going to return you a string. And the first part of it is node ID dash, and then you're going to have a base 58 check encoded address. And so that's how you get it. Just to remind you, we take the DER representation of your cert, we SHA-256 it, we write MD160 that, we take the 20-byte representation and we base 58 check encode it, and then prepend it with the string node ID dash. And we also use the SECP 256K1 curve on ECDSA Keypairs for, we have SECP addresses and SECP recoverable signatures. And the way we do the addresses are, we take the 33-byte representation of your pub key, and we SHA-256 that, take the resulting digest, ripe MD160 it, and then we actually encode it as BEC32. So we're big fans of BEC32. We think that Peter Woolley from Blockstream did a really great job. And BEC32 is base 32 instead of base 58. It also is easier to compute. There's no big num operations. It has superior checksums for prime power. It's 17% larger than base 58, but it's actually smaller when you encode it as a QR code. And it's in use in systems today like Tor and I2P and BTC and now Avalanche. So we're really big fans of BEC32, and we use this for our addresses. And then we also have SECP 256K1 recoverable signatures. There's 65 bytes. And you will see this same cryptographic primitive used on the Avalanche virtual machine, the platform virtual machine, and the Ethereum virtual machine. And the one thing to note of, we have this idea of feature extensions in our Avalanche virtual machine. So basically it makes it open-ended and we can plug in different feature extensions as we go forward. So today we have SECP feature extension, which is for issuing tokens like AVAX or issuing your own variable or fixed cap asset. And we also have a feature extension called non-fungible tokens. Everybody knows NFTs. NFTs use SECP 256K1 cryptographic primitive under the hood, but they have a different credential ID. And if we get around to signing transactions today, I'll point out what I'm talking about. But we have different types of credentials, and type number 9 is a SECP credential, and type number 14 is an NFT credential. And technically they're both using SECP under the hood, but we have them sort of divided into two different concepts, SECP credentials as well as NFT credentials. And so that is the cryptographic primitives that we use on the networking layer and the primary network. So I wanted to show this because this is a really great data visualization, or it's a visualization of our whole platform to give you a sense of how things look today on Avalanche. So Avalanche, as I mentioned, is a heterogeneous network of many different blockchains and many different validator sets. And so we have what is called the primary network, or the default subnet. It used to be called default subnet. I believe now we're changing the vernacular to primary network. But this is what is live now. This is live. Whenever we went to mainnet, this was live. And this is our network. This is Ava Labs' network. So it consists of 3 different blockchains, because if you remember, a network can have an arbitrary number of blockchains. And we'll discuss those blockchains here in one moment. And what we ask is that every single validator on our network validates our primary network. So if you fire up your own subnet and you're firing up your own blockchains, we ask that you first add your node as a validator to our default subnet. And that's actually the way the flow works whenever you're walking through the tutorials. You first have to add your validator as a validator on the default subnet, and then you can add it as a validator on your own subnet. And as I mentioned, there are 3 blockchains which are on our default subnet. So the first one is the X chain. This is for exchanging assets, such as I mentioned, SECP 256K1 assets. So the X chain is where AVAX, the native token, was issued. So AVAX is a fixed cap asset. There will only ever be 720 million AVAX ever. So it's like Bitcoin in that regard. You know exactly how many are there and how many will ever be there. And then you can also create your own SECP assets on the X chain. So you can create a variable capped asset, which means you're able to issue more tokens down the road, or you can create a fixed cap asset like Avalanche or Bitcoin. There's only ever going to be this number. That's it. Deal with it. You can also create non-fungible tokens. So NFTs are huge. I'm sure you know what's up with that. We have support for non-fungible tokens on our X chain. So you can create, so you can move AVAX, you can create your own variable and fixed cap assets, and you can create non-fungible tokens as well. If you look in the middle, you can see our platform chain. So the platform chain is like our administrative chain, our metadata chain. And oh yeah, let me go ahead and mention this really quickly since this is the technical deep dive. If you look at the X chain, it says Avalanche Consensus Protocol. And if you look at the P chain, it says Snowman Consensus Protocol. So we have two types of blockchains. We have directed acyclic graphs, which are one data structure. And then we have linear blockchains, which are another type of data structure. So depending upon the needs, depending upon your needs, you can hook into either one of those consensus. You get them out of the box. Avalanche is for directed acyclic graphs. So if you have like a type of transfer where things can happen in parallel and it could be prunable. So for example, Alice is sending AVAX to Bob and Carol is sending a non-fungible token to Dan. Both of those transactions could happen in parallel. And that would be a directed acyclic graph, a DAG. And we have Avalanche consensus for DAGs. If you are a linear blockchain, if you need total ordering and extremely high throughput and fast finality and low fees, so for example, if you're doing smart contracts, you need total ordering, you can use what's called Snowman consensus. And it's similar in the regard that it gives you extremely high throughput, fast finality, and very, very low fees, except it's optimized for total ordered linear blockchains, such as the Ethereum virtual machine, right? And so, okay, I just wanted to mention the different types of consensus protocols. Avalanche consensus for directed acyclic graphs and Snowman consensus for totally ordered linear blockchains. So our platform chain, as I mentioned, is our metadata and administrative chain. And this allows you to add validators, add delegators, spin up instances of blockchains, and create subnets. I believe I said create subnets. Yeah, so that's what our platform chain allows you to do. And then lastly, on the right here, you can see is our contract chain. So this is for doing smart contracts. This is an instance of the Ethereum virtual machine today. So we have 100% backwards compatibility with existing Ethereum developer tooling. So if you have a workflow around MetaMask and Truffle and Remix and OpenZeppelin and all of these different tools, you have 100% backwards compatibility with the Avalanche C chain. And that's very exciting. We, everything you can do on Ethereum, you can do on our C chain, with the added benefit that it has extremely high throughput, thousands of transactions per second, very fast finality, oftentimes far less than a second. And it's very, very inexpensive. So, you know, one of the things about Ethereum is that as it blows up and becomes more popular, you know, the transaction fees spike. That doesn't happen on Avalanche. We have scale and throughput for days, and our transaction fees are very, very, very low. And so, as I mentioned, everything you can do today with Ethereum, you can do on our C chain. We view this as an opportunity for developers to have an oversized impact with their work. Work that you do today could end up becoming critical ecosystem infrastructure tomorrow. And so we have a lot of biz dev deals going on behind the scenes of big Ethereum dApps, which you would know if I mentioned prototyping right now for the Ethereum, I'm sorry, for the C chain on Avalanche. So really the roadmap for the rest of the year is to really do a lot of integration with the Ethereum virtual machine. So I expect to see some just absolutely amazing stuff coming out of all the labs on the C chain by the end of this year. So again, that is our primary network. It consists of 3 different chains. We have the X chain for exchanging assets. We have the P chain for, is our platform chain. This is for doing things like adding validators, adding delegators, instantiating virtual machines, etc. And then we have the C chain, which is for doing smart contracts. One thing that's not clear here, but it does exist, is that today you can actually do cross-chain swaps between all of these three blockchains. So cross-chain atomic swaps are this holy grail of our industry. And the reason are, think about this, think about how much value is siloed in BTC and how much value is siloed in Ethereum. And it's not incredibly obvious and straightforward how one would move that value back and forth between those two networks. On Avalanche, we have baked into our core protocol this notion of cross-chain atomic swaps. So, you get this out of the box. You can move value back and forth between these three different chains. And it's on our roadmap to enable cross-chain atomic swaps through different networks. It's not currently live, but that's definitely on our roadmap. And that's going to be a huge, huge, huge value add whenever we have this thousands and thousands and thousands of these public and private networks all emerging into this global marketplace that we call the Internet of Finance. Having rails to move value in between all these different networks is going to be huge. It's going to lead to compound network effects. And so that's incredibly exciting. So that's our primary network. So really briefly, before we dig in onto our developer tech stack, I want to go over the challenges and the prizes which have been issued by Avalabs. So the first one is the challenge 1, follow a tutorial challenge. This slide needed to be updated. It says that there were 5 at $100 each. I believe we changed that now. I need to find out what it is, but it's more than that. I think we're giving out like 20. I don't know if you hear me, Anthony, but we updated.
Guys, it is slightly changed. I'm just going to find the, I'm actually going on the challenges thing anyway, myself. We've basically increased it so that you can do, we have more available. So right. It's £50 per tutorial, but you can only complete one of these guys. You have to follow the tutorial. And that's eligible to the first 40 teams that submit. So you can basically, there's 40 teams will get the chance to win 50 quid if you do it. But you can't, it's not like the case, sorry, there's a plant in my way. It's not like that you can do more than one. Anyway, no, I'll shut up now.
Thank you. No, you don't need to shut up. It's great. Thank you so much. I appreciate that. So yeah, as he mentioned, we updated it. So now we have 40 teams can win 50. So instead of it being 5 teams can win 100, now 40 teams can win 50. And so the idea behind this challenge is simply that we want people to be able to set up their development environments and walk through some of our tutorials. So if you look at the bottom, we have a URL there. That is our developer documentation. It's very thorough. We do a great job of keeping our docs up to date. And this challenge is simply to walk through one of those tutorials. So everything you can do on our platform, we have a tutorial for it. You can create variable and fixed cap assets. You can create non-fungible tokens. You can do cross-chain atomic swaps. You can fire up your own subnet. You can add delegators and validators to the default subnet or to your custom subnet. You can instantiate blockchains into your subnet, etc. So everything that is available on our platform, we have a tutorial for. So this challenge is basically just to incentivize teams to kind of do the work of setting up your development environment and familiarizing yourself with the primitives of our platform and being able to just walk through a tutorial. That's challenge number 1. Challenge number 2 is the Build on Avalanche challenge, and we have $1,500, $1,000, and $500 for the top 3 submissions. And again, this goes back to what I was saying previously, how we view Avalanche as an opportunity for developers to have an oversized impact with their work. So we want to launch a decentralized lending app like Compound. We want to launch a decentralized derivatives app such as Synthetics. We want to port over existing Ethereum infrastructures such as Amphura. And of course, we understand that Compound and Synthetics and Amphura are big apps. So we're really talking about sort of MVP type functionality. But what we want is large swaths of the Ethereum ecosystem to be ported over to the Avalanche ecosystem. So something like Infura is the perfect example, right? We need something like that. So who is going to build it? And the opportunity is huge for them to step in and claim that space. And as Avalanche grows over the next 2, 5, 10 years, their work today will have an oversized impact. So the work they do today will become critical ecosystem infrastructure tomorrow. And so that is our challenge number 2. And then challenge number 3, we have launch a custom virtual machine on Avalanche. So as I mentioned, we're a network of networks, a heterogeneous network with many different blockchains and many different validator sets. And today, when you fire up your own subnet, you can fire up an instance of the Ethereum virtual machine, the Avalanche virtual machine. We have a few sample virtual machines. We have a timestamp server. We have a very simple DAG, a directed acyclic graph. We have a very simple linear blockchain. But what we want to see, and where we think there's just going to be an absolute renaissance, is in custom virtual machines. So imagine spinning up a ZK-SNARK virtual machine so you could have a privacy-centric network, or imagine BTC Script so that you could do pay to pubkey hash or pay to script hash or SegWit, or imagine a BCH script so you could do check data sig verify, or you could do Schnorr signatures, or imagine a WebAssembly, a WASM virtual machine so you could use much more modern tooling, et cetera, et cetera. The sky is the limit here. And as I said, we really do think this is going to be an absolute renaissance, a creative explosion. This is subnets and virtual machines as blockchains is huge. Honestly, I've worked on many systems in my career. I've been very fortunate to work on some cool stuff. And the architecture of the Avalanche network is just beautiful. It is truly a thing of beauty. I have to tip my hat to Goon and Kevin and Steven and Ted and the rest of the team for just amazing engineering work. So yeah, so our final challenge is we have $3,000 to $5,000 available in the prize pool, and it's to launch your own custom virtual machine. Okay, so now I want to go over the developer tooling in our ecosystem. I just kind of want to step back and look at the different components and familiarize you with them, because if you're doing development in the Avalanche ecosystem, you know, there's a very, very high chance that you're dealing with at least one of these components, very likely all of them, because this is what the workflow looks like. So here's our ecosystem tooling. So first off, we have our web wallet. And the web wallet is absolutely wonderful. I've been into crypto now for about a decade, so I've seen a bunch of wallets come and go, and I genuinely think our wallet is wonderful. It's BIP44, so you know we use 24-word English mnemonics to encapsulate the entropy, and then we deterministically regenerate Keypairs. So if you've ever dealt with a BIP44 wallet, maybe you've used My Ether wallet, or maybe you've used a Trezor, or maybe you've used a Ledger. The point being, BIP, there's several BIPs. BIP is Bitcoin Improvement Proposal. There is no standard in Bitcoin, but there are conventions which effectively act as standards. So BIPs are the standards in Bitcoin land. And one of them, there's 3 of them that really work together: BIP32, BIP39, and BIP44. And those are mnemonics, deterministic key generation, and then this hierarchical deterministic key generation, which is like this big tree structure. It enables multi-currency and multi-account wallets. That's why you can use the same mnemonic, and you can go to your Trezor, for example, and you can plug in one mnemonic and you can go to BTC or BCH or LTC or whatever. And you can use the same mnemonic over on My Ether wallet and generate your Ethereum addresses. And this works because there is this, as I mentioned, it's like this tree structure, and you follow paths similar to whenever you follow like a path in a file path. You know, if you have an image tag in HTML and it's the source attribute has some path to where your image is, it's a very similar paradigm, but instead of the path leading to an image asset, it leads to a key pair. And so our wallet is very awesome. Our coin code is 9,000. So the way BIP44 works is each coin has its own code. BTC is 1. I think LTC is 2. I believe Ethereum is 66. Bitcoin Cash, I believe, is 144. Avalanche, or Ava, I should say, is 9,000. So we are the 9,000 coin code. Our web wallet supports mainnet, testnet, and local. So we have a local network, which I'll show you briefly, using this software called Avalanche. And then we have Fuji, which is our local, our test network. And then we have mainnet. And the wallet allows you to do portfolios. So of course you can have your different assets. It also allows you to manage key pairs. So you can import and export individual key pairs or mnemonics. It also allows you to send. So one of the cool things, the Avalanche virtual machine is incredibly expressive. So you can send AVAX, an issued token, a variable or fixed cap asset, a non-fungible token, all in the same transaction, while at the same time you're issuing more SECP and non-fungible tokens, all in the same transaction. So you can literally send AVAX, Gabriel token, Gabriel non-fungible token, at the same time minting more Gabriel 2 tokens and creating a new non-fungible token. Very, very, very composable and expressive. It's a very, very cool virtual machine. And then lastly, you can earn. So from the wallet, you can actually validate. You can set up your full node as a validator, or you can delegate. So the difference between validating and delegating is when you validate, you're keeping a node up 60% of the time or greater. You're keeping it secure. You know, all of that is on your shoulders. Delegating is when I come along and I say, you know, I don't totally think that I can keep a node up for a year, but I really trust Anthony. I trust Anthony from Encode. So I'm going to delegate my AVAX to him, and that will increase his node's weight, which increases its statistical chance of getting sampled by its peers. And then Anthony can charge me a fee, which he sets up himself whenever he fires up his validator. And then at the end of my delegation time, I will get back the funds which I delegated, plus whatever I made in rewards from Anthony's node validating transactions, minus the fee rate that he set out. And so this is all live today. You can delegate to people, and there's a marketplace right now where some people will set their delegation fee very high, but they give you, they handhold, they give you customer service. Some people set their delegation fee really low. They don't provide any guaranteed uptimes. They don't give any handholding, et cetera. So you pay for what you get in that regard. So this is our web wallet. Something also worth noting, everything I'm showing you is open source. So you can run the web wallet on localhost. So if you have your own local network, which I'll show you how in a second, you can use the web wallet, or we also have this faucet. All of this stuff will work on localhost. So if you're doing your own local network, you can have all of the different components of our ecosystem there as well. So the faucets go way back. So I got my first 5 BTC. I believe it's 5. If Gavin Andresen ever sees this, please correct me, because Roger Veer told me he only got 1 BTC from Gavin's faucet. So it's possible that I'm misremembering, but as I remember it, Gavin Andresen, the gentleman who took over from Satoshi when Satoshi stepped away, had a faucet, and you could go there and paste in your Bitcoin address and he would give you some BTC. And again, as I remember it, I got 5 BTC. I could be incorrect about that, but anyway, so faucets are, you know, pretty much, they're famous, and a lot of different ecosystems have them. We have a really great faucet, and our faucet allows you to receive X-chain or C-chain AVAX. So if you look here, the first address is a BEC32 address with an X-chain chain ID. So you can see it's BEC32 because it has a human readable part, which is AVAX, and then it has a separator. We use the number 1 as our separator. So you can tell this is a human readable BEC32 address, and then right below it, we have a C- prefixed hex encoded address, which is sort of the Ethereum native address format, except of course we have prefixed it with a C-. And if you were to paste either of these into this address bar, it will in fact send AVAX to either one of those addresses. So as I mentioned, we can do cross-chain atomic swaps. So you're able to send AVAX, C-chain AVAX basically, to this C-chain address. It's very cool, and we will do a demo of that. So again, similar to the wallet, this can run on localhost. If you're doing development on your local machine, which, you know, that's the proper professional workflow, localhost staging production, then you can fire these up, and it's very cool to have your own instance of a faucet where you can just keep dripping funds to your web wallet and then connect that with your DApp. So that's pretty cool. Okay, so now we have Avalanche. Avalanche is our local network. Avalanche is our answer to Ganache. Avalanche is the Avalanche shell. So if you've done Ethereum development, you know that there's this tool called Ganache, and it's a local simulated blockchain. The difference between Ganache and Avalanche is that Avalanche is a full-blown local network with 4 or 5 or 10 or 15 out of the box full nodes, but you can add more. All you got to do is basically create the TLS certificates for them. But Avalanche is a local network. As I mentioned, it can have my setup, which I'll show you briefly here in a second, is that I always have a 5-node staking network running. So if I'm doing local host development, I go to Avalanche, I fire up a 5-node network. Then I've got 5 nodes. They're all speaking to each other. And then I will send post requests to the JSON RPC of one of those nodes. The other cool thing about Avalanche is that, it's written in Golang, which is great. I love Go. But you can use Lua scripts to automate the state of your development environment to be in any state you want. So if you want to, whenever you fire up your brand new fresh node, if you would like to issue some of these tokens and send some to this guy and do this or do whatever, you can do that with automation. You can automate all of that with Lua scripts, and that's incredibly useful. I've done it many, many, many times. If I'm QAing a big workflow and I need to make sure different components are in a certain state as I work my way through this workflow, I'll automate that all with Lua scripts. It's incredibly, incredibly powerful. We also have Avalanche Go. So Avalanche Go is our full node written in Golang. It's a beautiful code base, man. Steven and Dan and Aaron, such respect to you guys. Truly one of the best code bases I've ever seen. These guys are absolute wizards, and the quality of their work is up here. They deserve a lot of respect. Avalanche Go has the full JSON RPC, so 100% of the functionality that you can do on our network, you can do over the JSON RPC. We ship binaries for Linux, Mac OS, and Windows, or you can just build it yourself. But just to make the on-ramp experience so much easier, we have pre-built binaries. And then below that, you can see the URL where you can go get this today on GitHub. As I mentioned, it's all open source. Next, we have Avalanche JS. Avalanche JS is our modern and idiomatic TypeScript code base. I'm a huge fan of TypeScript. The history of computer programming and software in general has always followed the same pattern over and over, where it goes from programming in the small and programming with low-level languages to programming in the large and programming with high-level languages. And that same cycle repeats over and over. So a code base today that we think is huge with an extremely high-level language, tomorrow we'll think of that code base as small, and we'll think of that language as too low-level, not expressive enough. And we'll have to, yet again, create a suite of abstractions which allows us to basically tame this ever-increasing complexity which is exploding all around us. So TypeScript is a superset of JavaScript. It does everything JavaScript does and more. And I am a huge advocate of TypeScript. If you're today working on the web in any part of your workflow, and you very likely are because the web is ubiquitous, I urge you to use TypeScript. It'll take your game to another level. It provides you the tooling to express yourself and to think about your abstractions much more clearly. If you take a .js file and convert it to .ts, nearly universally your dev tooling will pick up some type of small error simply because JavaScript is so incredibly expressive. So I'm a huge advocate of TypeScript. Avalanche JS has 100% of the JSON RPC of Avalanche Go. So today you can do post requests to everything. And we've got about maybe 85 or 90% of the transaction serialization. So today, you can keep private keys out on Avalanche Go and you can create transactions and everything. But if you want to do it all locally, not have your keys out on a hot machine, you want to create and sign transactions locally, you can do that for nearly 100% of the transaction serialization across the 3 different virtual machines. It's not 100% there, but we're very, very darn close. And that's what I'm working on basically this week. We also have some just great tooling in Avalanche JS. We have a Bintools library. So this gives you a bunch of utility functions for dealing with binary data in JavaScript for the client and the server and the browser. So we can decode and encode base 58 check strings to buffers. We can convert big nums to buffers, strings to buffers. Like basically we're able to turn higher level data structures back and forth between binary data or serialize it. Very, very useful. We also have SECP Keypairs. So as I mentioned, one of the goals of Avalanche JS is that we want people to be able to create and sign transactions locally. And so you can do that using the SECP 256K1 Keypair class. And then also we have Postman. So Postman is a really great suite for doing, it's a really great tool for doing collaboration around REST and API designs. And so since our JSON RPC of Avalanche Go is such a big part of our development ecosystem, we have a really great Postman collection that I maintain. And you can see it has, I believe we have 100% feature parity. I don't think I'm missing anything at this point. So I keep this very up to date. Anytime there's any update to Avalanche Go, I push this out on the same day. So if you're doing this workflow, and we're about to show you right now what the workflow looks like, you should be using Postman. So you should be using Avalanche as your local network, because you shouldn't even be on staging yet. You're just doing development. You should be using Avalanche, and you should be using Postman, because you're going to find yourself pasting a lot of curl requests to your terminal. And to save yourself some sanity there, it's way, way, way better to use Postman. And so again, as I mentioned, we have 100% of the JSON RPC for the Avalanche virtual machine, the platform virtual machine, and the Ethereum virtual machine. Okay, so that is a high-level overview of everything. My name is Gabriel Cardona. I'm developer evangelist at Ava Labs. You can reach out to me on Telegram or Twitter at cgcardona, or you can drop me an email at gabriel@avalabs.org. I get a lot of inbound messages, so if you email me or ping me and I don't reply immediately, please bear with me. I do try and reply to everybody. So now I think I have around 9 minutes or so left. I want to briefly sort of just go over some of the development workflow that I mentioned. So Anthony, can you confirm, if you're there, that you can now see my terminal? Or anybody else? Can I get a thumbs up?
I can see that. All good.
Okay, excellent. Thank you, sir. Okay, so now I want to really briefly kind of just go over some of the different components which we just discussed. So the first one is Avalanche. And as I mentioned, Avalanche is our answer to Ganache. It is, instead of being a simulator though, it is a full-blown network. Excuse me. So to give a sense of what my workflow looks like every day, I will fire up Avalanche, and then I'll say, Avalanche has a bunch of really great utility. The ones I use mostly are proc manager, run script. So you can also call RPCs, you can have your own wallets, you can really do a lot here. But the ones that I deal with are proc manager, run script, and start and stop node. So let me show you what that looks like real quick. So whenever you fire this up, let me go to the code base real quick. So you can see that there is this scripts directory, and there are a bunch of baked pre-shipped scripts. So the one that I would recommend you using is 5-node staking.lua. And so this fires up a 5-node staking network. And the way you do that is you just say run scripts /5-node staking.lua. So now we have a 5-node staking network running, and I can say proc manager list, and you can see that it shows me the name of my node, node 1. It gives me its status, and then it starts giving me the metadata, like what flags I either passed in my Lua script or which ones we have set by default in the Avalanche Go code base. And something that's worth noting is you can see that we have this stash directory. If I run tree stash, you can see that it creates, so for example, here is node 4. It creates a DB structure for each one of the nodes. Remember, I have 5 of them. And then for each one of the chains on each one of the nodes, right? So we have the C chain, we have the P chain, we have the X chain, we have a bunch of these other chains which have launched. They're going to be the timestamp server, the simple DAG, the simple linear blockchain. And you can see that it creates this database tree structure for every single one of the nodes. And so that's pretty cool. So if you want to go fishing in the logs, you can do that. They're super verbose and super extensive. But something I do, which I think is a nice little thing to be aware of, is you can say proc manager stop node 1. And so that killed node 1. You can prove it by saying proc manager list, and node 1 has stopped. You can see right here. So now when I say proc manager start node 1, it fires it back up, but more importantly, it gives me this command here. And you can take this command. So let's go ahead and stop it again. And then you can go to another tab and you can fire that up, and it will fire up that node with tailing debug logs. So this is incredibly handy because if you're using Avalanche Go, for example, right here, and I'm on my localhost environment and I want to say like info.get something, right? Let's do this in info.get network ID. You can see it's 12345, which means I'm on my local network, 3039 in hexadecimal. But what's cool is you can see here it says info.get network ID called. So this is hugely awesome. If you are doing work and you want to get an insight in real time into what's happening, you can run proc manager, stop node, fire it back up from the command line and get the logs in real time. So the workflow that this would look like is, for example, we would come over here and we would create a user. So I don't know if you know how Postman works, but you can have different Postman collections, which can plug in environment variables. So you can see like right here, I have 2 environment variables, Avalanche username and Avalanche password. And then up here, I have multiple different environments. And so we're in our localhost environment now, which I don't mind showing you the values of because it's going to be not value bearing. So you can see that I have these different environment variables that I can plug into my Postman collection. And the ones that are worth paying attention to are like this private key. We call it the EWOQ, EWOQ. This is the whale on the local networks, 12345's network, X chain and C chain. So if you're doing localhost development and you need a grip of AVAX and you don't want to go to the faucet and drip it 10,000 times, you can import this EWOQ key on your private local Avalanche network, and you will have millions of AVAX for doing testing. So I'm going to go ahead and create a user. Boom, it says true. So now I have this user. I can say list users, and it's going to say that Gabriel is the user. If you go to avm.import key, so I'm going to now import that private key, which I just showed you, which you can see. All right. Sorry, this thing is in my way. How do I get this to close? There we go. Sorry. So right here, for example, you can say code, and it will show you exactly what's being passed in, and it's that EWOQ private key. So when I send it, it returns a localhost address, and now this has been imported. And if I come over here and I say get balance, and I pass in that same address and ask for AVAX, it's going to tell me you have a lot of AVAX. So now, for example, you can create a fixed, so if I go get all balances, pass in that same address, you can see that I've only got AVAX. But if I then go to create fixed cap asset, for example, I'm going to have a mentor set of just myself, or I'm sorry, this can't be minted because it's a fixed cap asset. So I'm just going to issue 400 of this new test token I'm creating. There will only ever be 400. There is no possibility to mint this later. If I click go, send, it was successful, and I can tell that by multiple ways. I can get this transaction ID, and I can go over to avm.gettx status. That's one way. So it's going to say accepted because it worked. Or I can go over here and say get all balances and pass in my exchange address. And sure enough, I now have 400 of this new asset, which I issued. If I get that asset ID and I go to get asset description and pass it in as the AVAX asset ID, you can see that it will tell me test token. It will give me the name of it. So now let's do a cross-chain. So that was creating a token. You can also create variable and fixed cap assets. You can create non-fungible tokens. It's going to follow a very similar workflow. So if we wanted to create a variable capped asset, You can see it's called my variable cap asset. There's only one minter, myself, and I only have to have one address to mint. So I'm going to go ahead and create it. You can see it created it, but it didn't issue any of them. So if I say get all balances, I don't yet see that. So I need to come down here and say mint. And then I will go to the body of this post request. I change the asset ID, and I'm going to basically be issuing this many of these new tokens. Boom, it was successful. And I can tell by going to get all balances, hitting send, and you can see now I have that many of that particular asset. So that's creating assets on the X chain and minting them. One other thing, because I only have got about literally a minute or left or less, I want to show you cross-chain atomic swap, and then I'll wrap it up, Anthony. So really quickly, I'm going to go over to the platform VM. I'm going to import that EWAC key. So if you look at the code, you can see it's EWAC here. And then that will now give me a user who has some funds. If I go to get balance, you can see that I now have unlocked tokens, and I even have locked tokens. They're stakeable, so you can stake locked tokens, but you cannot spend them, of course, because they're locked. So now I have a grip of tokens. So the last thing I want to do, I want to show you two things. I'm going to do a cross-chain atomic swap of AVAX, and then I'm going to do a cross-chain atomic swap of one of these other assets I created. We call them ANTs, Avalanche Native Tokens. So if I go to export AVAX, and I want to send this to the P chain, you can see, let's see here. I'm sending this much AVAX from the X chain to the P chain. Boom. So you can see that that worked. And if I go to avm.getAllBalances, it's now my AVAX asset balance is going to decrease, which you can see that it did right there, that 5. And then if I go over to the platform VM now and I say import AVAX, so you can see that was successful. And if I now go to get balance, you're going to see this balance increase. So you can see right there with a 4. So it has been an hour. I want to be respectful of the time. I know there might also be questions, but that is just a general high level of the Avalanche platform. As I mentioned, my name is Gabriel Cardona. I am a developer evangelist at Ava Labs. You can reach out to me at CG Cardona on Twitter or Telegram, or you can drop me an email. Thank you so much.
Awesome, Gabriel. Thank you very, very much for that. We would give you applause if that was a thing. So let's run through questions. I don't know how much you covered throughout the event, but I'm going to just grab some stuff. So the first thing is, are tasks for the challenge 1 to be done on testnet or mainnet? Oh, you're muted, by the way. Oh, wait, I think I need to unmute you. There is logic for this.
Okay, I'm unmuted now. Yes, it said I couldn't unmute. So I think that testnet is probably sufficient. I want to confirm with my teammates because if you do it on the mainnet, then you're going to have AVAX, and you probably maybe you don't have mainnet AVAX because that's worth actual money. So I think testnet or staging Fuji would probably be sufficient. Let me confirm with my coworkers, but at this moment, I believe that you can do it on either Fuji or your local network.
Great. Next one, are exchange chain and cross chain and contract chain connected to each other? Can X-chain assets be used in C-chain contracts?
They can. So I wish Aaron was here. Aaron, if you're here, one of my coworkers I have asked to join. He's the one who maintains our
joined, yeah.
Oh, hey, Aaron. Did you hear?
Let me just let him. I'll unmute him.
Hey, yeah, sorry, I wasn't able to unmute. Could you repeat the question one more time? Hello, can you guys hear me?
Can you repeat the question, Anthony?
Oh,
yeah, I hear you.
Okay.
It was, are exchange chain and contract chain connected to each other? Can X-chain assets be used in C-chain contracts?
Yeah, absolutely. I've been working on this for the past 3 weeks, actually. So these assets, once they're moved over to the C-chain, they're not immediately ERC20s like most assets on Ethereum are, because those assets actually have to be contract balances. We can't just kind of spontaneously create a smart contract to monitor these when somebody wants to import these funds over to the Seas chain. So what we do is we actually create an account balance for all accounts on Ethereum whenever they have an asset moved over to them. And so then that has to be wrapped. So once Apricot comes out, I've been working on the additional precompiled contracts in order to support this. So after the Apricot release, we'll be able to move X-Chain assets over to the C-Chain and then wrap them in the same ERC20 interface that people are used to working with on Ethereum.
Awesome. Cool. From Mork, can you run heavy validation such as zero knowledge proofs in a virtual machine, or are computational resources limited?
Yes, as far as I know, you can do zero knowledge ZK-SNARKS in virtual machines. I believe that Tcrypt, Tyler Smith from our team, I think he might have even had a prototype virtual machine with ZK-SNARKS working. I don't want to overstate that, but I believe he was at least working on one if he didn't have a prototype. But yeah, we absolutely see huge value in privacy-centric networks. I personally believe that privacy should be a basic human right, especially in the world now where we have total information awareness, and every single one of our action leaves behind 1,000 different digital footprints. We should be able to have privacy. And so, yeah, we're huge advocates of privacy and privacy-centric networks. And we definitely see, we envision privacy-centric networks launching as subnets using things like ZK-SNARKS on Avalanche. Aaron, if you want to add anything, we can jump in anytime.
Awesome. Next one. Well, let's go. Sorry, I'm down to scroll through. Are there any Avalanche Ethereum bridges to transfer stablecoins?
So yeah, we do have multiple bridges in the works. I don't think I can give too many details, unfortunately, because I believe that they might be under NDA or we're working with other partners, and I want to be respectful of my coworkers and our NDA type relationships. I don't want to offend anybody or get in any trouble, but yeah, there are bridges in the works that you'll be able to move over native existing Ethereum tokens into our ecosystem. Do you want to add anything to that, Aaron?
Yeah, on top of the bridges that we're building to connect Ethereum, we're also currently building bridges to connect other networks as well. We're going to have wrapped Bitcoin, wrapped ETH, wrapped pretty much anything. But yeah, definitely agree with Gabriel. A lot of this stuff is still under NDA, but we're hoping to have announcements coming out soon, announcing all the cool stuff that's coming out through the bridges.
Great. Okay. What is this validation that Subnet is doing? Is that like mining or conferring transactions context? This might be a bit from earlier, but if you know what that means.
Sure. So they're saying, what is the validating doing? Yeah. So it's sort of an equivalent of doing mining. It's validating the transactions and confirming that there's nothing being double spent, and confirming that the signatures are correct, and updating balances and that kind of stuff. So yeah, it's akin to mining.
Excellent. Okay, next, let's do, what is the TPS like if you have complex validations such as zero knowledge proofs?
Do you want to take that one, Aaron?
Yeah, so we've seen TPS up to 6,000 transactions per second on our exchange chain. When we haven't had a prototype with zero knowledge proofs, obviously we would expect the transactions per second to be a little bit less when you're doing much more computationally heavy resources. So that kind of remains to be seen. But yeah, that's about as good of an answer as I can give right now. But definitely we're hoping to see how we can do on those.
Okie dokie Koki, I was muted there. So let's go. Is it possible to help us visualize the virtual machines or subnets in the context of AvaX, perhaps?
In the context of what?
AvaX or Avalanche.
Is it able to help us visualize that? Can you flesh that out a little bit? What exactly do they mean? Visualizing?
Kengus, if you want to say more, that would be great and very useful. We'll move on to the next one. Patrick says, how does an app built on smart contracts differ from one built as a virtual machine?
Well, Aaron can weigh in after this, but basically whenever you're doing a smart contract, you're locked into using Solidity. I don't have a lot of experience with Vipers, so I don't exactly know how expressive it is, but you know, a Solidity app is like a contract, right? It's got the contract data structure and it's got the ABI and, you know, it's got that sort of API. Virtual machines can be nearly any arbitrary logic. There is a certain API that you've got to interact with, but you know, it doesn't look like a Solidity contract. It's a big Go code base, you know, so it can be just incredibly expressive, and you can use languages other than Solidity and Viper. You can use Golang today, but like I said, in the future, you'll be able to use Rust and C++, etc. So I think it's just, as I perceive it, smart contracts are very sort of, they box you into this one way of thinking, and virtual machines allow you to break out of the box and to be able to express yourself more fluently and in a way which doesn't automatically map to sort of like this contract data structure.
Sure.
Yeah, absolutely. The EVM is basically just one example of a virtual machine that you might want or have. And so it's extremely extensible. You can use Solidity in order to create a huge range of different applications on it. But one of the things that this costs you is the fact that because of that extensibility, there are a lot of things that you might not need it to do that it needs to account for doing. And so that can have performance implications where, since it has to be able to do more things, it might not perform the things that you care about quite as well. And so for something that if you want to create a private network that's going to do one thing really, really well, then you can design that as a virtual machine specialized for that exact task. And it also allows you to specialize, make it as performant as possible to do that one thing. And it also means that, like Gabriel said, you're not locked into Solidity. We can build virtual machines that are going to run different smart contract languages. You can build your own, or you can build something that's much simpler to do one very simple task. And so, yeah, I think it's a little bit more extensible in a way, but obviously you can run any kind of smart contract language as just one example of a virtual machine.
Awesome. I think we're pretty much at the end. Mork says something, so Rust, C++ in the future. I don't know if that means something to you. Well, obviously I'm not Rust and C++ up, but I missed the bit where that was mentioned.
Yes, you will be able to write virtual machines in Rust and C++ in the future.
Okay, cool. All right, guys, I think we're broadly at the end now. I'm conscious of time. So thank you everyone for attending, and Gabriel and Aaron for your help as well. Thank you so much for this event. It's really invaluable for the general education part of the hackathon to have such a great talk. So thank you very, very much, and we're looking forward to the second one, I think, that's scheduled for a few weeks' time. For the rest of the hackers, I'll make sure we send through the slides and the video for this. We have a couple of events coming this week and more coming pretty much every week. We also have, very lucky to have Gun, the CEO of Avalanche, giving an AMA to the crowd. I think that's on Thursday, the 3rd of December. Yes, this will be, everything is recorded, everything will go on YouTube, subject to a little bit of editing by me tonight. Any questions, guys, please find me on Discord. Otherwise, enjoy your evenings, afternoons, and nights, wherever you are. And Gabriel, thank you very much, and see you all soon. Thank you.